Hello, I'm Carly McAvoy. Today I'm talking about adding and subtracting like fractions. When we say like fractions, we're saying fractions that have the same denominator. To add or subtract like fractions, you combine the numerators but keep the denominator the same, then reduce if possible. Reduce can also be called simplifying. So if I was adding 1/7 plus 3/7, those are like fractions because they have the same denominator. I'm going to use a pencil and shade in. I have a figure with 7 boxes that represents the 7 parts of my denominator. 1/7 would shade in one of these boxes. 3/7 would shade in 3 of these boxes. In addition to the one that we already have, that makes 4 boxes shaded out of 7 possible boxes. That's why the denominator doesn't change. We're talking about shading basically the same shape. If I was talking about subtracting, for 4/5, I would be shading all 4 of these boxes, right? And then I'm going to subtract 1, which means I'm going to go back and erase 1. I'm taking one of those away that I started with. And what does that leave? That now I have 3 shaded out of 5. So notice we subtracted the numerators, kept the denominator the same. So like fractions are easy to work with, but we also have to remember the other part that I said, reduce if possible, because sometimes you can simplify, and you always want to simplify your answers to lowest terms. In this one I have 8 boxes because I have a denominator of 8. I'm starting off with 7, so I'm going to do this. I have 7. Now I'm going to erase one of those. I'm taking 1/8 away. So let's take this one away. And what's left? What I have left is 6 eighths. 1, 2, 3, 4, 5, 6 eighths. But that can be reduced. And you may notice that because it has a even number on top and bottom. So we can reduce that by dividing by 2. And if we divide the top and the bottom by 2, we get 3/4. Does 3/4 make sense for our picture? Well, it does, because I can think of this instead of being 8 individual parts. I could break this up into 4 parts. This is 1 part. This is 2 parts. This is 3 parts. And this last piece would be 4 parts. Those parts that I drew in ink are 4 separate parts. And notice that 3 of those 4 parts are shaded, which means 3/4 shades the same thing that 6/8 shades. We just wouldn't be thinking about that little line down the middle of those boxes to get to fourths. Okay, and 3/4 plus 1/4. Well, I have 3/4, and then I have another fourth. Anytime you shade a box completely, that's one whole. So that is 4/4, but anything divided by itself is always equal to 1. So if we had something totally shaded, we would say that that's just equal to 1. Here's a word problem. Jamie worked 5/8 of an hour setting up for the job on Monday and 7/8 of an hour breaking down the job on Friday. What is the total number of hours it took her to set up and break down the job? Well, we have 5/8. Going to shade all the way across here. And then I'm going to shade one more to get to 5. So I have 4, 5. But that's 5/8. Now I want to shade 7/8. Do you see how I only have 3 parts left? I can't just draw one more block because that wouldn't give me 8 parts. I need to think about drawing 2 parts. And I did this kind of crazily. Here, my handwriting or my drawing is not so great. But what I'm thinking about is having another set of 8 because I'm going to go outside of my original box. So I have 7. I can do 3 more here. But then I'm going to have to shade 4 on this. So in this case, I have 1 whole plus I have 4/8. Now, I can't ever leave something as 4/8 because that's not in simplest form. So I would divide the top and the bottom by 2, and I would get 1 and 1/2. Do you see how if I looked at this second box, where'd my pen go? My second box as 2 parts, this being 1 part, on the top, and this being 1 part on the bottom, there's 2 parts. And that one top part is shaded, that's the 1 out of 2 parts total. So again, 1/2 and 4/8 are equivalent fractions because they shade the same amount of the box. What does this look like though? Originally I have 1, 2, 3, 4, 5, 6, 7, 8, all 8 of my boxes, 9, 10, 11, 12. So I have 5/8 plus 7/8. Keep the denominator the same and add the numerators. I have 12/8. Is 12/8 the same as 1 1/2? Well, 12/8, we can reduce that. We can change that into a mixed number. 8 goes into 12 one time with 4 left over, and then 4/8, as we said, was 1 1/2. So you can get this by looking at the picture, but you could also just do the math of it. I want you to understand, though, what's happening. Okay, we're going to look next at fractions that have different denominators. Have a great day.